This Zoom session has been brought to you by the Fractal Diagonal Quadro Gasket. I admit I like my Synesthesia Street invitation there, especially since pretty much all these fractals I made myself using a Xerox machine. Okay, we proceed. Today we go on to synthetic division and solving rational equations. Why is this taking so long? I'm on a machine. There we go. There we go. What? Okay, synthetic division is specific for dividing a polynomial by x minus c. Now the reason why is it turns out this is useful for evaluating a polynomial at c. So let's start off with dividing 3b squared minus 31b plus 13 by b minus 3. It goes through this process, and we'll abbreviate this by a process called synthetic division, which is pretty much the same, only some signs are flipped. So we start off with b minus 3 into 3b squared minus 31b plus 13. We divide the leading coefficients, leading terms. 3b squared over b, that's 3b, which we'll put into the quotient. Then you multiply 3b by 3b minus 3, 3b squared minus 9b. Then we subtract. Now, what will happen here is we'll change this minus 3 to a plus 3. And here we subtract, but here we'll add. The result being the same. Anyhow, 3 minus 3 cancels. Negative 31 minus negative 9 is negative 22. Divide negative 22b by b, you get negative 22. Put that into the quotient. Negative 22 times b minus 3 is negative 22b plus 66. Subtract, we're left with a remainder of negative 53. So the ratio is 3b minus 22 plus negative 53 over b minus 3. Now we'll do the same thing in an abbreviated fashion by something called synthetic division. The idea, we start off with a 3, negative 31, 13, and we put them here. And instead of having a b minus 3, we put a plus 3 here. So we flip this sign from here to here. Then we'll do this kind of zigzag process, where every time we go down, we add. Every time we go up and to the right, we multiply by this positive 3. So bring down to 3, that's a 3, same as this 3 here. And 3 times 3 is 9. Here it's a negative 9, here it's a positive 9. Here we subtract, here we add. Negative 31 plus 9 is a negative 22, same as this negative 22 here. Then we multiply the negative 22 by a 3, you get a negative 66. Here was a positive 66. We subtract here, we add here, get a negative 53. And so this gives you the coefficients of the quotient, 3b minus 22 here. And this negative 53 is the remainder, which we put over, in this case, b minus 3. So like I say, it's pretty much the same process here as here, only here we put here we have a negative 3, and here we have a positive 3. Here we subtract, here we add. Those two cancel each other out, so you get the same result. And the advantage of this synthetic division is that it's so much more compact than this. It's, it takes up less space on the paper, and also we don't have to carry around any variables, b squared, b, whatever. And well, okay. So it's just a lot less punctuation. All right, let's proceed. Number 2. Hello. Ha. Yeah. Why is it being like this? Okay. All right, here we're going to try 4t cubed minus t minus 18 over t minus 2. Now, because it's a minus 2, we'll put a plus 2. And oops, notice there's no t squared term here. So we'll have to put a 0 where the t squared is. So we have a 4t cubed, a 0t squared. We need a placeholder. It's like 0 is a placeholder in decimal numeration. Minus t, so a minus 1. Minus 18, so a minus 18. Now, here every time we move, we do a zigzag process. And every time we go down, we add. Every time we go up and to the right, we multiply by this 2. So bring down a 4, you get a 4. 4 times 2 is an 8. 0 plus 8 is an 8. 8 times 2 is 16. Plus a negative 1 is a 15. Times a 2 is a 30. Plus a negative 18 is a 12. And so this is the quotient, and this is the remainder. 4t squared plus 8t plus 15 plus 12 over t minus 2. Here we're going to have, oh man, here they deliberately wrote it in this all mixed up form. X squared, x minus 4x squared plus x cubed plus 6 over x plus 1. Now this needs a number of adjustments. First, we need to put this in descending order of powers. And write this x plus 1 as an x minus negative 1. So I'll write x cubed minus 4x squared plus x plus 6 over x minus negative 1. So inside this synthetic division tray, that's what I call it, we put the coefficients 1, negative 4, 1, and 6. 1, negative 4, 1, and 6. X minus negative 1, so we put a negative 1 right outside. Here we go. And again, the zigzag, add going downwards, multiply by negative 1 going up and to the right. So down comes a 1, times a negative 1 is a negative 1, plus a negative 4 is a negative 5, times a negative 1 is a 5, plus a 1 is a 6, times a negative 1 is a negative 6, add that 6 and negative 6, you get a remainder of 0. So the ratio is just will be the quotient given by 1x squared minus 5x plus 6 with 0 remainder. Jane Kim, I see you just came in. Anyone else come in while I was in the last few minutes? Oops. All right, here we go. If we divide polynomial p by x minus c, and we get a quotient plus remainder over x minus c. Then if we multiply through by x minus c, we get the p of x equals q of x times x minus c plus the remainder. And then in particular, if we set x equal to c, then this c minus c is 0, so this all vanishes, and what left is the remainder. So p of c is the remainder. So evaluating a polynomial at c, you can do synthetic division, and the remainder is the value. So for example, p of x equals 2x cubed plus x plus 0. What's p at 3? Now I could put in a 3 here and here, but you'd have to have 3 multiplications here and a couple of additions. That's not so fast. Whereas this actually is a lot faster. Okay, so we put 2, 0, 1, 2, a 0x squared term here. And we put, for a 3, we put the 3 here. And we do a zigzag. Every time we go down, we add. Every time we go up and to the right, we multiply by 3. So down comes a 2, times a 3 is a 6, 0 and 6 is 6, times a 3 is an 18, 1 and 18 is a 19, times a 3 is a 57, plus a 2 is a 59. And there you have it. This is p at 3, it's 59. And it took only 1, 2, 3 multiplications and 1, 2, 3 additions. Whereas this is about the same number, but for this, oh, it's definitely faster. Because here you need 4 multiplications, 3, 2, and 1. That's like 10 multiplications and 1, 2, 3, 4 additions. So all right, where this will be a lot faster. Okay, so we have this polynomial, 4th degree polynomial. I want to find its value at -2. So put the coefficients 1, -2, 1, -3, 2. Here, 1, -2, 1, -3, 2. Put -2 out here. And the zigzag is adding, going down, up and to the right, we multiply by -2. So down comes a 1, times a -2 is a -2, plus a -2 is a -4, times a -2 is an 8, plus a 1 is a 9, times a negative 2 is a negative 18, plus a negative 3 is a negative 21, times a negative 2 is a 42, plus a 2 is a 44. P at negative 2 is 44. So like I said, this would have required 10 multiplications and 1, 2, 3, 4 additions. This only required 1, 2, 3, 4 multiplications and 4 additions. So it's faster, especially considering that multiplication is harder than addition. All right, let's see. Huh, why is it being so slow? Huh. I'm sorry, it's acting slow today. It's kind of warm in here, maybe it's suffering. All right, here we go. So here we do examples from 6.6. 5x squared minus 27x plus 10 over x minus 5. What's the ratio? Well, all right. Oh dear, I guess I should have done this by synthetic division. Well, doing it by long division. Ha! Embarrassing. We get, well, 5x minus 2. Here we have a 31b cubed minus 31b plus 13. We have to put a term 0b squared in for a placeholder. And oh dear, I didn't do this by synthetic division. Well, whatever. You get this quotient here, and this remainder here. So 3b squared minus 9 plus 9b minus 4 plus 1 over b minus 3. I dare say I probably did this the wrong way in all these cases. Ha! I'm doing this all by long division, and it would have been a lot faster to do it by synthetic division. Anyhow, this one, they deliberately messed up the numerator. X minus 4x squared plus x cubed plus 6. So first put it in order. X cubed minus 4x squared plus x plus 6 over x plus 1. Well, okay. I'll step through this one by long division, though like I said, I really should have done it by synthetic division for this section. X plus 1, x cubed minus 4x squared plus x plus 6. Ratio of leading terms is x squared into the quotient. X squared times x plus 1 is x cubed plus, this should be an x squared. 665 x squared. Subtract, get a minus 5x squared plus x plus 6. Minus 5x squared over x is minus 5x into the quotient. Multiply it out. Minus 5x squared minus 5x. Subtract 6x plus 6. 6x over x is 6 into the quotient. Times x plus 1 is 6x plus 6. Subtract. No remainder. So the ratio is just the quotient. X squared minus 5x plus 6. Really, maybe I should redo all the notes to do synthetic division. I really should redo all this by synthetic division because this is not the way they were asking for it. But anyhow, again, we have this all mixed up numerator over x plus 5. We write it in descending order, 2x cubed plus 7x minus 3x plus 8 over x plus 5. And we go through the whole process. 2x cubed over x is 2x squared. Multiply that, 2x cubed plus 10x squared. Subtract minus 3x squared minus 3x plus 8. Minus 3x squared over x is minus 3x into the quotient. Times x plus 5 is minus 3x squared minus 15x. Subtract 12x plus an 8. 12x divided by x is 12. That should be a 12. 666. And subtract 12 into the quotient, multiplied by x plus 5 is 12x plus 60. Subtract negative 52. So the ratio is the quotient, 2x squared minus 3x plus 12 plus the remainder negative 52 over x plus 5. Maybe I really should redo all this in the canvas. All right. Number 7. Finally, I do it the proper way. They want to find p of x is x cubed minus 4x squared plus x minus 2. What's p at 2? All right, so we put the coefficients 1, negative 4, 1, negative 2 in the tray here. We put 2 right outside, and the zigzag is the add going down and multiply by 2 going up and to the right. Like this. So down comes a 1, times 2 is a 2, plus negative 4 is a negative 2, times 2 is a negative 4, plus 1 is a negative 3, times 2 is a negative 6, plus negative 2 is a negative 8, and that is p at 2. Okay, we're done with this part. I'll stop recording for now.